We're going to look at the series from 1 to infinity of cosine of 1 over n. We want to know if this series converges or diverges. And we'll be using the test for divergence. Now, this test is often overlooked. When we look at the series, we see that this is not a geometric series. We should try test for divergence because it can save a lot of time and effort. Here's what test for divergence says. Suppose we have a series an. It doesn't matter where we start with 1 or 2. And if we take the limit as n goes to infinity of an, and this limit is not 0. So not 0 means it could be like 10 or 1/5 or 1/15, or it could be undefined altogether. As long as it's not 0, then the series diverges. That's what test for divergence says. But you have to be careful because sometimes people misinterpret it, and this is what it does not say. So it doesn't say if the limit n goes to infinity an is 0, then the series converges. It may converge, but it may also diverge. So what you should say is, if the limit as n goes to infinity of an is 0, test for divergence is inconclusive, and we have to try something else, some other technique. So returning to our series from 1 to infinity cosine of 1 over n, we look at the limit as n goes to infinity of cosine of 1 over n, and that can be rewritten as cosine of the limit as n goes to infinity 1 over n. Of course, this limit is 0, so this converges to cosine of 0, which is 1. And 1, of course, does not equal to 0. And we can now use the test for divergence to conclude that the series from 1 to infinity cosine of 1 over n diverges, and we can say why by the test for divergence. And so that's the appropriate way to use test for divergence. Now if we look at a similar series, say n equals 1 to infinity sine of 1 over n, and we apply test for divergence, then we look at the limit as n goes to infinity sine of 1 over n, and that of course goes to sine of 0, which is 0. Test for divergence is inconclusive because of 0. Now if you mistakenly think that because we got 0 the series converges, that would be a mistake, because in a later video you'll see that this series in fact diverges. For more videos, visit www.mathprepvideos.com.